All right. So we're talking about obviously 10.2 special pairs of angles. First one we're going to talk about is adjacent angles. Okay, two angles that share a common side and a vertex but do not overlap are called adjacent angles. Now, in our problem here, the adjacent angles here are angles 1 and 2, okay, angles 2 and 3, angles 3 and 4, and 1 and 4. Okay. Now they've chosen to draw two intersecting lines that form four angles. Another way that we can look at it is this way. If we have a 90-degree angle that's intersected by another angle, it forms two adjacent angles. What they're talking about, what we need to talk about when we talk about overlapping, okay, if I was looking at this big angle here, okay, that's an angle, okay, from here to here is an angle, okay. It overlaps three different angles. So that one big angle, we could call it angle 5, right there, could not be adjacent to angle 2 or angle 3 or angle 4 because it overlaps them. It could be adjacent to angle 1, okay? In other words, this angle here could be adjacent to this angle, okay? But it could not be adjacent to angle 2, angle 3, or angle 4 because it overlaps those angles, okay? So that's basically, if I added another line, let's say I did this in here to the one I drew, okay? So now you have 1, 3, and 2, okay? Well, angle 2 and angle 3 can be adjacent, but angle 1, and then you have the bigger angle right here that goes all the way there to there, okay? So basically it can't overlap. Adjacent means next door. Okay, if you want to think of it in our terms today, your neighbor next door would be adjacent. How many of you have been in a duplex before? A duplex is a big house, but it has two different people living in the house. They have two different sides. They have a shared wall, okay? But that would be adjacent. That would be the true meaning of adjacent, is when you think of a duplex and you have the person on the left side of the house and the right side of the house, but they share a common wall, but their houses don't overlap each other. In other words, the kitchen of house number 1 is not in the kitchen of house number 2. Okay, they share a common wall, but that's it. They don't share anything else in the house. Okay, so a real good example of, in our world today for adjacent would be that you're in a duplex, you're in one side of the duplex, and you're in the other side of the duplex. Okay. So that's what they're talking about when they talk about adjacent. Now, adjacent angles don't have to be congruent. Okay, they can be, but they don't have to be. When we get down here to vertical angles are going to be congruent. Okay, vertical angles, when two lines meet at a point, okay, basically, I don't really like that definition, but basically your vertical angles are the 1 and 3. And the 2 and 4. Basically, vertical angles are when two lines intersect each other, forming four angles. Okay? The opposite angle is vertical. Okay? The opposite angle is vertical. They are also congruent. Okay? When two lines intersect each other, forming four angles. Okay? Understand that I can have a line, that's why I'm saying four angles. I could have a line like this and a line that intersects it right there, okay? But that doesn't form any vertical angles, okay? It's got to be two lines intersecting each other, and they form four angles. The opposite angle is congruent, and it is vertical, okay? So that doesn't matter. It doesn't matter if my line looks like this. Let's say I have this, okay, where these angles are real small, 1, 2, 3, 4, okay, still doesn't matter. Angle 1 and angle 3 are going to be congruent. Angle 2 and angle 4 are going to be congruent. They're opposite of each other, okay? They're going to be congruent every single time, all right? So you got to make sure that you understand the difference between a adjacent and vertical. That's the first one that you have to understand and know the difference of, okay? Because they are not the same. Let me get here to it. Right there. Okay, so they are congruent. Vertical angles are always congruent. So anytime you have two lines that intersect each other and form four angles, the key there is four angles. In our example up here, there's only 1, 2, 3 angles that are formed with that intersection. That's why they're not vertical angles. Okay, that's why they're not congruent. Okay, because there is no opposite angle because there's not four of them. Okay, but that does form three angles. Okay, when you intersect a line like we've done there, you have 1, 2 on top. Of course, these two have to be 180 degrees. Okay, and they have to be supplementary. Okay, because anytime I intersect a line with another line, the two angles that are formed are going to be 180 degrees. Just like down here with our, well, let's go back up to the original drawing here. Let me erase my marks on it. Okay, just like here, these two angles have to be 180 degrees. Okay, these two angles have to be 180 degrees. Okay, anytime you have a line that intersects another line, okay, you have 180 degrees of angles. Okay, the reason being is because every straight line is 180 degrees. Okay, so if I intersect it with another line, whether that line goes all the way through or whether that line stops, I'm going to form two angles at least, 1, 2, that have to equal 180 degrees. When I run all the way through the line with the intersection, like I've done there, then I'm going to form four total angles. So angle 3 and angle 4 have to be 180 degrees. Angle 1 and angle 2 have to be 180 degrees. But so do angle 2 and 4 and angle 1 and 3. They have to equal 180 degrees. So it forms two angles that are supplementary, meaning they have to equal 180 degrees. Okay? When I intersect the line all the way through, then I create vertical angles. Okay? Then I create vertical angles. Now, in our drawing here, the adjacent angles would be 1 and 2, 2 and 4, 4 and 3, 3 and 1. That would all be adjacent angles because they share a common side with a common vertex. That's what makes them adjacent. They share a common side with a common vertex. Okay? All right, now, that moves us into the next part. We need to talk about plane. We need to talk about parallel lines. We need to talk about perpendicular lines. And we need to talk about corresponding angles. Okay? All right, now, a plane is a flat surface. Okay, a plane is a flat surface that extends without end. Okay? Now, understand that for our purposes, we have to cut off planes. In other words, for us to show a plane, either drawing it or by a picture, we have to cut it off. We have to end it. Okay? But a plane, just like a line, these lines that we're talking about up here, these lines, you have to remember, extend infinitely. Okay? For our purposes, obviously, we have to end them. We have to draw them. Okay? So, obviously, I can't draw a line that extends infinitely. Okay? Because there's no way we could bring it into a room. Okay? It extends infinitely. It means, we're hitting people down in, Mexico with it. When we bring it into the room to show you, it's hitting people down in Mexico. It's knocking people off the freeway in Mexico or wherever. Okay? So obviously, when we're talking about lines, you have to imagine them as infinite in their continuing path. Okay? But for our purposes in math, we have to cut them off. We have to stop them. So you'll see examples of planes on page 480. Okay? You'll see an example of a plane on page 480. Another example of a plane is this book. Okay? It's a flat surface that could continue on forever if we didn't need it as a book. Okay? Obviously, you don't want a book that's infinite. That would be bad. Okay? That means your homework would be infinite. That would be bad. Okay? That would be bad for you. All right? So, as we look at the plane that they've given us example on page 480, okay, I can draw a plane, and it's going to basically, in our area, it's going to look like, didn't want it drawn that quick. Drew it quick there. Let me select it. No. Okay. Well, that's fine. Okay. That's a plane. All right. It's a surface that could continue on. In other books, they will say a lot of times a plane is made up of 3 collinear points. Okay. In other words, it's a surface that has 3 points in it that it's containing. This book does not do that. It just talks about being a flat surface without an end. Okay. So that's what you need to understand that's what you need to understand what a plane is. A parallel lines also are talked about in a plane, okay? The parallel lines are lines that are contained in the same plane but do not intersect, okay? A parallel lines is 2 lines. Parallel lines, the wrong one there. Is 2 lines that lie in the same plane but do not intersect each other. Okay? Parallel lines are 2 lines, okay, that lie in the same plane but do not intersect each other. The best way that we've talked about in the past, we've talked about this in 6th grade, is if you think of a railroad track, when a railroad track is going straight, okay, obviously not when it's curved, but when it's going straight, it's out in the country and it's just moving straight for a long period of time, that would be parallel lines, okay, because the lines are the same distance apart at all points, okay. The railroad track is the same distance apart at all points, okay. So if I was drawing 2 parallel lines, I would draw a line like this, okay. Then I would draw another line right there, okay. Now, those are 2 parallel lines because if I did this, if I took a point A and a point C and measured that distance between those 2, if we went between those 2, it would be the same distance as if I had down here point B and point D. It would be the same distance there. Okay? Now, obviously, if the lines are infinite and they continue on, the least little degree of change in the line would eventually make them intersect. Okay? But as we look at this picture, it looks like, yes, they're running the same distance apart. They would be in the same plane, and they would never intersect each other. Okay? Now, if I drew two lines that look like this, however, if I drew one like that, and then I drew one like this, okay, those two lines are going to eventually intersect if they continue on. You can obviously see that. Obviously, to the left, they're getting closer, okay? Obviously, here, they're closer than they are there. So that would not be a true example for parallel lines, okay, because they're going to intersect each other, and therefore they're not going to be parallel, okay? So that's the difference between parallel lines and regular lines. Now, when we have two lines, okay, we have two lines, and let's say they are parallel. Okay, and then I intersect them with a third line that we call a transversal. Okay, that is a transversal. It is a line that intersects two other lines. Okay, if, and we will call this line AB, line CD, and line EF. Okay. Line AB, we would express it like that, that's how we name it, is parallel to line CD. Okay, that's how we would state something is parallel. This is the symbol for parallel. Okay? This is the symbol for a line, and that's how we name a line. Okay? So, if it says line AB and CD are parallel, then here's what happens. We have corresponding angles. Okay? The corresponding angles here would be, let me go ahead and write the numbers in, 1, 2, 3, 4, 5, 6, 7, 8. Okay? The corresponding angles here would be angle 1 and angle 5. Okay? The reason that they are corresponding is because they hold the same place. In other words, if I don't have this top picture, okay, this would be the upper right. Okay, the upper right, upper left, bottom right. Same is true up here. Angle number 1 is the upper right. Angle number 2 is upper left. Angle number 3 is bottom left. Angle number 4 is bottom right. They hold the same place. The 4 angles on top and the 4 angles on bottom hold the same place. Okay? And so that would be a corresponding. So your corresponding angles here, your corresponding, I've got to get the tip on my pen changed. The corresponding angles are angle 1 and angle 5, or angle 8 and angle 4, or angle 7 and angle 3, or angle 6 and angle 2. Okay? Those are your corresponding angles. Okay? Now, when the two lines that you intersect with the transversal are parallel, then those corresponding angles are congruent. They are the same. So, let's take, for example, then, that I said angle 1 is 60 degrees. Okay? Well, having learned what we have learned today, you can fill in the other 7 angles. Okay? Here's why. We first talked about vertical angles, or let's see, we first talked about adjacent angles, correct? So, to angle 1, what is the adjacent angle? 2. So, if angle 1 is 60 degrees, we said adjacent angles have to be supplementary, which is 180. So, what does angle 2 have to be? 120. So, this has to be 120. The second thing that we talked about was vertical angles. We said that vertical angles are formed when two lines intersect and form 4 angles. We also said that vertical angles have to be what?
90 degrees?
No. No, they have to be congruent. Okay, they have to be the same. So, that means that angle 2 and angle 4 are vertical angles. So therefore, angle 2 and angle 4 have to be 120 degrees. Okay? Now, angle 1 and angle 3 have to be vertical angles, and therefore, that angle 3 has to be 60 degrees. Okay? Now, we can use the final thing that we talked about today, corresponding angles. Corresponding angles happen and are congruent when the two lines are parallel. So, we said that angle 1 and angle 5 are corresponding. So that means angle 5 has to be 60 degrees. Now we can use the same thing we did up top on bottom. 120, 120, and 60. So there's all 8 angles with their measurement, and all I did is give you the first one. Okay? Now, if these two lines, A and B, line AB and line CD, are not vertical, then it changes things. Okay? It changes things, and then your corresponding angles would not be congruent. They would be different. Okay? And there's some other things that we'll talk about in another section that will help you with that. But right now, most of the ones you're going to deal with are parallel lines that are intersected by a transversal, and it forms congruent corresponding angles. Okay? So, turn the page. Okay? Turn the page to page 483. I want you to look at the brain game down below on page 483. Better yet, we'll do that in a little bit. Look at page 482 right across the page at numbers 26 through 29, or 24 through 29. Look at the little house. Okay? Look at the little house there on page 482. All right, bear with me 1 second. All right. Now, as we look at the house, okay, and the angles of the house, okay, number 24 says find the measurement. Says find the measurement of angle 1. Okay, so we got to find the measurement of angle 1. What is the measurement of angle 1? Why?
Because it's a 100, it's a supplementary angle.
Okay, it's a line that intersects another line, and it forms two angles that have to be equal to 180 degrees. So, number 1 then is 63 degrees. So, if that is 63 degrees, then let's look at the next one. What is the measurement of angle 2? This one will be a little difficult because it's not as... Why? No. Okay, what did we say? Are these two lines parallel? Yes. Do you have a line that intersects them? Yes. So this is the upper angle, this is the bottom angle, so that's the same angle as this, because it's corresponding angles. Okay, so angle 2 is 117 degrees. Okay, now, angle 3 is easy. It's 90 degrees because that's a right angle. So that means 4 is 90 degrees. Okay? So, it says here, this angle right there is 58 degrees. Right here is 58 degrees. Okay? So, now we have to look at angle 5. Why is it 53? Oh, that is. Okay, I thought you meant number 5 was 53. That's what I thought you were saying. So, yeah, it's okay, it's 53. Okay, so what is then number 5? 53. Why? Because they're parallel, and it's a corresponding angle. So it is 53 degrees. So that makes angle 6 what? 123? 127. Because it has to be 180 degrees between the two of them. Okay? So given the two angles, we are able to figure out, because of all the different types of angles that are there, the rest of the angles. Okay? So, your homework. Your homework is 10.2, 3 through 30. 3 through 30. Yeah, 3 through 30. Okay? Got about 5 minutes left. You can start on it, get probably at least first 5 or 6 done.